Hi, I'm Stefano Pando. I will voiceover for my friend Marty, who will fabricate a flat panel with an electroluminescence sheet to do flats for image calibrations in deep sky astrophotography. Let's see what we can find on the internet that we can print in 3D. Like a crafted design that we can find on thingiverse.com. Now I see what I was looking for. Here it is, and it's also placed on a telescope. We will use this one, but we will have to modify the size of its circumference to fit onto the telescope. I'm looking at the various sizes. Let's open these files in the 3D printer. The program I will use is Cura for 3D printers. Let's start with the main enclosure. I will flip the main base to 180 degrees. And here is the hole for the bridge, which is shown in red. The material is in the air when it prints, so it creates a little block that you will extract afterwards. Next, in the printing settings, I have to enable Build a Support. I see that it's enabled already, so we will leave it that way. This would take 10 hours to print. Meanwhile, let's save the file in a USB key or memory card. It's saved in the project folder. Okay, so I'll see you guys at Marty's 3D printing room. We are now in Marty's printing room. Let's put the memory card with the files in the 3D printer. The surface is hot, good. The nozzle is hot too. So I think we can load the project and proceed to print. My bed is 75/75 and I set my nozzle temperature to 235 Celsius, waiting for it to be a little higher before the printer starts the job. Printer begins printing. It makes a nice circle, which will be defined as the outline of the main base, which will be the cover of the flat panel. As you can see, it is definitely bigger than the main base. The green tape makes it adherable so that the base doesn't slip while it's printing. Aluminum platforms are too slippery. The filament that I use is PETG. It is less toxic than the ABS, which is more common, and has a certain flexibility to it too. Now we let the printer do its job for 10 hours. Here is Marty's telescope, a 65mm quadruplet refractor. Let's measure the circumference of the dew shield, which is 87.7 millimeters, and we will round it off to 90 millimeters so that the cover of the flat panel is not too much of a tight fit. Now we will adjust the circumference to 90 millimeters onto the dew shield of 87.7 for the telescope. As you can see, there are different sizes. I will choose the 80 millimeters. So we will reduce the size of the circumference of the tenon. To do this, I will use the program Fusion 160, free for personal use. Go to Mesh, choose and insert the design. Let's place it correctly. Let's get the measurements of the circumference, and it gives us 100.5 millimeters, but we want to resize it to 90 millimeters. So in order to do this, let's place a circle inside the tenon, making it a solid circle, and afterwards we will extract the circle so that it will be empty again with the new size. This looks like an hydraulic press where you push in and push out. As I'm pushing in, I will stop at the rim, which will result in being 15 millimeters of thickness. Okay, let's select a circle inside with the size of 90 millimeters that we will extract later with the hydraulic press diagram. Now I filled the hole and will set the size of the circle inside to 90 millimeters. If I push it inwards, it will erase and make a hole as you see in red. Push it out, it's filled. Push it in, it's empty. So in theory, I just reduced the hole to 90 millimeters. We will choose Print 3D in the menu and Convert Mesh. It's this part that I convert. To combine both, I have to select all of it. Now I will print Convert Mesh to Solid. Both are combined, and now it's ready to print. Exporting it in 3D as a STL file. Let's go back to Cura. The design is imported. Looks good. And I am pivoting it to 180 degrees. 7 hours to print this. See you at the printing room. Okay, hours later, let's take it off the surface area. Now let's tear away the support block that's inside the hole of the cover base. Need to apply force, so let's use different tools. As you can witness, it's stuck a little bit tightly. Here we go. Now we proceed to take out the little supporting block with a knife and pliers. It takes a little bit of strength. And muscle. Finally, now you can see the finished product of the flat panel. Here's the back base of the cover, where I insert my electroluminescence sheet and the pieces hold together as a unit that fits onto the telescope. I can add a little bit of tape if I want it to be tighter, but it's not necessary. I will add a little bit of glue to keep the pieces together. Let's light it up. Oh, nice. The whole unit goes onto the top of the telescope, and now you can do your flats like this for your astrophotography image calibration. I just need to get rid of the AC cord unit, 5 volts. To replace it with a little battery pack with 3 AAA batteries with an on and off switch. the battery pack is holding with a Velcro, and with a little less voltage will be in favor for doing flats. I can't wait to try this. Bye for now. Thanks for watching. I hope this video was helpful for those who like to build their own devices. Stay tuned for more videos about astronomy. And don't forget to subscribe. It's very important to us. Clear skies to all.